We have Ravi Poudel from Gold Coast, is that right? On interacting digital twins with BIM for enhanced HVAC energy efficiency in buildings. A review of applications, benefits and challenges.
Hello everyone. My name is Ravi Poudel and I'm a PhD student. I'm based on Gold Coast campus and I'm working with Faculty of Science and Engineering. And today, it's been 2 months that I've started my PhD, so I may not have so much in depth to say about this topic, but I'll try to explain what my understanding is until now. So today I would like to explain to you about 2 different tools which could be used for enhancement of HVAC systems, heating and ventilation systems in buildings. So the 2 tools would be digital twin and building information modeling. I have abbreviated it as BIM here. So that's what I'll be talking about today. So I'll cover on these topics, introduce to you some jargons and technical terms, and then I'll tell you something about HVAC systems, and then some insights on the difference between traditional and modern control system, and then why should we use digital twins and what are its benefits, and then something about building information modeling, and then how we can integrate these 2 tools and benefit from that integration. And then finally the future implication, what future holds for these 2 technologies. So UN has forecasted that in 2050 we would have population around 9.7 billion. And the urban population is targeted to rise by 66% in that time. So we would be consuming a lot of energy in the future. And buildings, they do consume 40% of the total global energy share, and that's quite a lot. So, and the heating and ventilation systems inside the building, it again consumes around 40% of the total energy that buildings are consuming. So when we see this scenario, the HVAC systems are, they are covering a lot of energy consumption when we compare the total energy consumption around the world. And here are 2 graphs for your insights. It's on the right, we can see that the energy consumption of building, which is compared between 2023 and 2024, all around the world, it has tri-folded in 1 year. So looking at this scenario, we will, the buildings will be consuming a lot of energy in the future, and since HVAC are consuming a lot of energy in the building, so how we could reduce the amount of energy that is consumed by buildings is one of the cases could be that we could have more efficient HVAC systems. The HVAC systems which are very dynamic and adapt to the situation, adapt to the number of occupants inside the building, adapt to the weather outside the building, so as to consume least amount of energy and hence reduce the amount of carbon footprint that buildings are generating. So to talk about HVAC systems, they are pretty all around us, and their function is to heat the space, cool the space, and also control the quality of air inside the living space. But they have many limitations. They have drawbacks, like they are very energy intensive, they consume a lot of power, and they require regular maintenance, and they have pretty high initial cost, and things like that. And also, when we think about or talk about the refrigerants that is used in these systems, they are very potential greenhouse emission gases. And HVAC systems, if they are not well designed, if they are not very efficient, they would consume a lot of power, they would create discomfort to the people living indoors, and the quality of air would be low, and when the quality of air is low, people suffer from sick building syndrome. Sick building syndrome covers a wide range of symptoms like nausea, dizziness, irritability, itchy skin, and sore throats, and many things. If the quality of air inside the building is not to the thresholds and the system is not maintaining a proper quality of air, then people would suffer with this kind of syndrome. So it's important to design very good HVAC systems for the betterment of the occupants living inside a building. So let's discuss about the control system. I'm putting this here in order to highlight the importance of modern control system and why we should try to integrate such modern tools like digital twins and building information modeling. We have two systems in comparison here. One is the very traditional classic system, and another one is the modern system. The modern system does refers to the system that we are trying to achieve with integration of digital twins and applying tools like building information modeling. So classic tools have drawbacks like they have only preset values for the control. I mean, let's take example of this hall. So there are quite a lot number of occupants at this stage, and there could be at least 1 or 2 occupants in some days. Let's say there is very small symposium, like 5 or 6 people are there, and then what the traditional control system would do is it would still pump the same amount of air and still try to maintain the same temperature inside the hall. When there are a lot of, let's say the hall is full, there are hundreds of occupants inside it, then in both the scenarios, the classical control system would do the same. So that means when there are less number of people, they don't require such amount of airflow. So these traditional control systems are very inefficient. So what we are trying to achieve, what we would like to achieve is develop a system, a modern control system, which would sense the number of occupants inside the building and sense what's the surrounding temperature outside the building, and what's the amount of carbon dioxide being produced inside the building, what is the amount of particulate matters, and many different variables, and then optimize the system dynamically to consume less amount of energy and to make it optimized to the number of occupants that is present inside the indoors and to other different variables. And other things include like modern systems do use very sophisticated sensors, but classical systems have very less sophisticated and less costly things. So in the long run, though modern systems have very high initial cost, it would eventually offset the cost in the long run. But for the classical systems, it would have very less initial cost, but in the long run, it would have more amount of energy expenditure and cost. So to talk about a digital twin, there are a lot of definitions of digital twin, and there is no a universally accepted definition. But here is what NASA has tried to define digital twin. It's a lot, very complicated. But what we can basically say is that digital twin is a personalized and dynamically evolving model of a physical system. So it is like a complete replication of a system into the digital world. So it would have all the different sensors that a physical system has. It would have all those systems like virtual sensors, the 3D models, and every detailed thing that a physical system has. And it would also have systems like real-time data integration and real-time dynamic evolution of the system. So why is it important? So there are many variables to think about. If we are thinking about optimizing a space with many different variables like occupant numbers, all those parameters of air quality, then it is a very complex decision to make. So in order to optimize things in such a complex scenario, digital twin would come very handy because digital twin can simulate the systems in virtual environment so that we can have prediction of multiple number of future outcomes so that we could select the best outcome that is coming from the best set of variables. And it also help to balance the contradicting objectives, like we want thermal comfort, a very comfortable environment indoors, but we also want less amount of energy to be expended. So it seems contradicting, and this kind of situation can also be handled by digital twins. And it predicts multiple futures. It is continuous analytical system and which adapts with time, and then it can also be used as new source of data since it can simulate number of different multiple future outcomes, you can use it also as a source of data for those outcomes. And also, it can be used for optimization. So to talk about building information modeling, it is a little bit similar to digital twin, but it is a static system. It doesn't evolve dynamically. It just has static information about all the dimensions and all the components that is installed inside a building. So we will have a tool that has complete replica of the building, but it doesn't contain real-time data and it doesn't evolve with time. And here are some uses that we generally use BIM for, like crash detection, 3D modeling, energy simulations, and things like that. Okay, and why would it be important to integrate these two systems for HVAC systems? So the benefits would be that we could have detailed effective analysis, and we could include all the HVAC component sensors in a very effective way into the simulations, and then detect faults and inefficiencies that may occur in future or that has occurred at present. And our building would start to perform better. And then we can also plan for virtual commissioning of any systems, like we would design the system and virtually commission it in digital space. And then after that, if everything is good and it's going well, then we can go for a physical commissioning. And also enhanced decision making. So this is a framework how digital twin can be integrated with BIM. BIM would have all the geometric data, all the data of semantic and spatial informations, and then digital twin will have all these real-time data from sensors, and the new systems also integrate AI and ML to process the data in order to optimize it, and then digital twin could simulate this system in virtual environment, and it could take all the data from BIM of a building and could simulate that in virtual space. So in this way, integrating BIM with digital twin would help us to minimize the manual input of data to the digital twin system. Since we would have already available BIM models for buildings that have been constructed, then we can use all the data from BIM to the digital twin. So these are the benefits of integration. We would have advanced analysis of HVAC system, automated tool chains, and then there would be common data environments. And challenges would be, there would be higher amount of computational requirement. And there are also challenges regarding interoperability of two different tools, because if we are developing digital twins, then we won't readily get the data out of the already available commercial tools, because they would not allow sharing their data across any other platforms. It's unless they are open sourced. And also there is a challenge with standardization of this mechanism. So what futures hold is when we integrate digital twins with BIM, there will be more and more integration of AI and machine learning into the system, and there will be more avenues for high performance computing. And we could also plan for multi-scale digital twins, not a digital twin of a building, but digital twin of a whole city or whole urban planning. And then industrial metaverse also could be one of the avenues to be merged, that would merge with these systems. And then we could also have fully autonomous digital twins in the future. So thank you. That's all from me. So I'd like to welcome any questions.
Thanks, Ravi. That's another really exciting project and taking us all into the future. Yes, we've got some questions in the audience.
Thanks, that was a great presentation. Really interesting to see something different.
Thank you.
I was wondering, when you had challenges up, you didn't have cost. So I wondered, is it cost prohibitive at all, or the cost doesn't really matter because it's going to be so great? Do you know what I mean?
Yeah, I understand what I mean. Maybe I haven't very much looked into the cost aspect, but in the long run, it should be that when we are using this dynamic system, in the long run, if we are able to save a lot of energy, as we know that population is increasing, cities are expanding, so it should be less costly when we think about in a long time span.
Hi Ravi, that was a very good, interesting presentation.
Thank you.
I have a follow-up question to that about the cost. Looking at the long-run economic footprint of the building, do you think that we can maybe use a mixed system, like not fully dynamic? Maybe we can make the system give recommendations to the users of the building that maybe you should open the windows or like close the shutters of the building. So it's like a mix between fully dynamic and the users can do something about the temperature, and that will actually reduce the carbon footprint more, because the system can shut down based on what they do, if they like open the windows or close the windows, something like that.
Yeah, thank you for the very insightful question. Actually, we did had some discussion regarding this kind of hybrid system, hybrid approach, so that we can have user inputs, like not just the system is using mathematical models or data from the past year, but also get some user feedback. Like if you are feeling a comfort, comfort could be very personal. I mean, it is very subjective, right? So if you are in any situation, you could feel comfortable, but I may feel uncomfortable in that temperature, at that humidity level. So we could utilize the user feedback, who was the user of different rooms sitting in a building, and then also create a data for all around the year of how do they feel or what their feedbacks are within the 1 year of span, and use that data in future to again optimize the system. So yes, that could be a very effective way of doing that. Thank you.
Just one more. So how hard would it be to make a digital twin of a building, let's say, that is already established like 20, 30 years ago?
Sorry?
Like how hard it would be to create a digital twin of a building like from 20 years ago or something?
Okay, if the building does not have a BIM model, then we would have to get all the dimensions of the building. So maybe we can use rapid data generation tools like 3D scanning to get the 3D models. And then for the other parts, like the systems that are integrated inside the building, we would need a lot of manual entry of the data. So it would take quite a lot of time to do that for an old building. But again, when we see the long-run benefits of doing that, then I think it's good to do that rather than not doing for the old buildings. Thank you.
Thanks, Ravi. We've probably got time for one more question for Ravi. Oh, Kennedy, good on you, mate.
Thanks, Ravi. Very engaging presentation, and I love, the modernization.
Thank you.
Just a thought when you were presenting your, and also talking about the challenges. If you consider also the complexity that comes with these systems, from my background in engineering, complex systems, they get to be much more harder to troubleshoot when we're looking at issues, looking at maintainability and reliability. Maybe just something to consider, as well as the security aspects, because, for example, worst case scenario, you're looking at a system, you got a digital twin, and then there's a breach in between the two, and then the system doesn't shut down. The system goes high, there are kids in the house, the system does not shut down. Quite not easy to work around.
Yes.
Just some thoughts on that. Yeah.
Yes, thank you. Thank you for the suggestion. I'll keep that in mind.
Well, look, thanks very much for that, Ravi. And that sounds like a great work in progress, and look forward to seeing you back next year as well.
Thank you so much,
For an
Craig.
update. Okay, thanks, Ravi.